भूपेंद्र।
अब देखिए एक बार आवाज आ रहा है क्या मेरा? अब आ रहा होगा वेबिनार में। गो टू वेबिनार। हेलो। अच्छा फिर मेरे को बता दीजिए, ठीक है? Good afternoon, all of you.
Hello.
Hello, Bhupender ji, can you hear me?
Yeah, I can hear you. Can you hear me?
Yeah, perfect.
Okay, please.
So we'll just start the webinar.
Yeah.
So friends, I welcome you to the Firstgreen webinar series of technology trends in PV modules. And this webinar series brings you, along with me, Mr. Bhupender Singh, Mr. Bhupender Rawat from Renewsys. Just a brief introduction about Firstgreen. We are a leading consulting firm in solar as well as green building. We have done over a gigawatt of solar projects as consulting and EPC, and we bring that experience in these webinars to you. We have got some 40 platinum certified green building projects as well, apart from our solar experience. We work in India as well as abroad, and this is a great experience we bring to all of you in the form of various types of webinars. Here you can see the webinar is being presented by me. I am Sanjay Vashisht, and with me we have Mr. Bhupender Rawat. He is Head of Business Development in Renewsys. The agenda for today's webinar. So the first session will discuss about how the solar cell technology developed. We have almost 5 decades of experience, started in 1950s when the solar cell was developed in Bell Laboratory, and it has got a lot of technology transformation. So we will discuss about history of solar cell architecture, technology innovations, and what is the current status of technology and what is the way forward. Of course, with Mr. Rawat, we will be having discussion how this technology is being adopted by Indian manufacturers, what kind of innovations they are doing to make it cost effective, what kind of quality control measures they are taking, and he will also highlight how this technology will be taken in future. Just to give you a history of solar cells, in 1954, Bell Labs silicon solar cell was developed. At that time, the efficiency was about 4%. Of course, later on, this was improved and the cell efficiency reached to 11%. In 1950s to 60s, the solar cell technology was well established and it was to be utilized for NASA's space exploration program to power the devices in the satellites. So, of course, solar panels are now in great use, and these days we have got solar planes as well. So the earlier uses were of the order of using these solar panels in satellites, and the cost was something like $200 per watt. We had a great journey, and in 1970s there were efforts to reduce the cost of the production of solar panels and solar cells, and there was a project which was funded by Exxon, and Dr. Elliot Berman they brought the cost reduction from $200 per watt to $20 per watt. And friends, today we are somewhere around 20 cents per watt. That is the journey which we have been doing. Technology has moved from various phases. So in early 70s itself, we had back contact technology, which is quite predominant today. The screen printing technology was also adopted during early 70s only. Uh, we started using the solar panels for household application, and some of the initial application was that President Jimmy Carter, he told we should install solar panels on the White House, and in 1979 32 solar panels were installed on the White House. As of date, we have had a great journey, and we have reached the cell efficiencies 47% plus, almost 50% we are reaching to cell efficiencies. Various technologies have come up apart from crystalline silicon. There are thin film technologies also competing with this technology. Of course, today's discussion we are doing more on the crystalline silicon technology, because most of the market is dominated by the crystalline silicon technology. Of course, the cell efficiency is of the order of 47 to 50%. The module efficiencies have also reached as high as to 40%. Just to give you a modern solar cells structure, so you have got a rear contact, that is also known as back contact. It's a layer of conductive material, and there is a base material, and we have got the emitters. In the solar cell, we have texturing on the front surface, and we have got fingers which are collecting the electrons from the top. And these fingers are connected to the bus bar. So this is a typical solar cell structure. This typical solar cell size is 6 inch by 6 inch square, and thickness is about 180 micron. This thickness is being reduced through laser cutting technologies and various other methods, and the cost reduction measures are being adopted to improve. Solar cell is now coming in, multi-layered cell, and with various materials are also being tried apart from crystalline silicon. So that is what the modern solar cell technology at the moment. There is one more technology which has come up recently in market, that is known as integrated back contact technology. It is also known as IBC technology. So what it does is that the back side of the material, because these fingers which we are putting on the front of the cell is obstructing the sunlight, so it is better to collect electrons from the back side of the cell, and that is what the back contact technology. It improves the cell efficiency by another 3 to 4%. Otherwise, the solar sun rays are not falling on the top surface. So this is also yet another technology. Maybe Bhupender Singh ji, Rawat ji will be giving us some more details about these technology developments. There is one good technology we all are hearing, that is PARC. That is passivated emitter and rear cell. So again, here also the screen printing is done on the AL paste, and a passivation layer is made on the back side, which is improving the generation. And on the top there is a AG paste, which is done as screen printing. So this silver paste is also collecting this. The top layer is done with AR coating, that is anti-reflecting coating, and this is how the PARC technology is getting very much popular in this market. So what lies ahead? We have got half-cut solar modules. So the earlier cells are having modules are having cells with 6 by 6 inch size. Now the cells are cut half. It means the earlier cell was producing about 8 amperes current. Now the half cut cell will produce about 4 amperes current, but it will reduce the resistance of the module. So if the resistance increases, then overall module power increases by 5 to 10 watt. So at the same time, when we cut the wafers, and in the process of cell manufacturing, many cell get damaged. So this also improves the utilization of the wafers and cells which gets damaged during the manufacturing process, because cell is a very thin material. The next type of module technology which we will find a lot of development in the market is bifacial solar modules. The solar cells are laminated between the glass layers on the front side as well as on the rear side, and you are able to generate electricity from both sides. So not only the front side is generating electricity, but back side is also generating electricity. This improves the overall module power, and that's the reason nowadays we are getting solar modules 2 meter by 1 meter size, of the order of cell. Uh, Individual module power is about 450 watt. So that is even up to 500 watt we are getting the bifacial. About 25 to 30% power is being generated from the rear side of the module. Then there's a technology that is multi-junction technology. So currently, single junction solar cell is recovering electrons from a particular bandwidth of your solar spectrum. And if it is multi-junction cell, then you have got different bands from which the power is being recovered from the solar spectrum. And the solar system efficiency or solar cell efficiency improves significantly, and this has breached that barrier of 33%. So earlier, single cell efficiency could not have been more than 33%, and now we are reaching to 48, 49, close to 50% efficiencies we are reaching. That's because we are using multi-junction solar cells. Then there is one more technology which is multi-layer cell technology. Almost 140 layers of different solar uh, collectors are there in the cell, and we collect a wide range of spectrum, and this increases the cell efficiency to the tune of 50%, as I was telling. So there are a lot of technological developments happening in the market. Not only the PERC technology coming, mono PERC is quite common. The PERC technology is also moving to the Pearl technology. That means we are developing this as a locally diffused technology, the passivated emitter locally diffused technology. That is the Pearl technology. Means we are putting multi layers within the cell itself so that the large band spectrum can be captured. So I will not take much time, but we will be listening to Bhupender ji. But what will be the future technologies that will dominate? So just to give my view about it as a closing slide. So there are many technologies, especially in the crystalline silicon, and it is very difficult to say at the moment that which technology will be competing. There are many technology, and which technology will compete, that will be decided by still research innovations. Nobody thought that the cell efficiency will reach to 50%, but now it is reality that cell efficiency we have reached to 50%. There is a capacity which is installed today that is almost 90% plus capacity is using crystalline silicon. So as of date, the technology which is dominating is the crystalline silicon cell technology. In recent last 2-3 years, we have got mono PERC technology which has taken modules 400 plus watt individual modules, and that technology will remain at least for near future until some new technology comes. But there will be 3 factors which will be dominating: the increased efficiency, then the reduced material uses. So like we were talking about the laser cutting technology and so many other, or reduced thickness of your wafers. So those things are also being explored. In fact, the wafer thickness has been tried right up to 120 micron. So that is the level means we are able to save. And because it is laser cutting technology, not necessarily the traditional sewing technology, so your material waste has also been reduced, and the reduced manufacturing cost, especially how the Indian companies are targeting to compete the international suppliers, is based on their ability to manufacture at low cost, at the same time maintaining high level of reliability. We'll be hearing that thing from Mr. Rawat as well. And we have got, concerns in terms of, the reduced tariffs. And these reduced tariffs are forcing the module manufacturers to come up with better technologies and better cell efficiencies and low cost modules. And that is the reason from 6 mm thickness, we have got to less than 2 mm thickness glass as well. So wherever it is possible to improve efficiency of PV module, and we are doing it, at the same time trying to bring the modules at low cost with a high level of reliability. Thank you very much for your patience hearing. Your questions you can keep posting in the chat box. And I will have now Bhupinderji with me, and we will have understanding from Bhupinderji that how, as an Indian manufacturer, they are able to manage the modules at a cost-effective manufacturer. Bhupenderji, can you hear me?
Yeah, hi.
Yeah.
Greetings. Yeah.
Yeah. Thank you. If you can give few lines about your company and yourself, that would be great.
Yeah, hi. Greetings, friends. This is Bhupender Rawat. I'm heading business development in Renesas India Private Limited. So we are the first integrated module manufacturers out of India. Not only manufacturing solar modules, but its key components like encapsulants, which is EVA and POE, and backsheets, plus solar cells. So we are a part of NP Group. We have two manufacturing setups, one out of Fab City, Hyderabad. It is a SEZ, where we have 750 megawatt of solar modules capacity, installed capacity, and hello.
Yeah,
Am I audible?
Yeah, you're audible.
And we have crystalline silicon manufacturing installed capacity of 130 megawatt. The other plant, which is in Bangalore, Jigni, we have 1.4 gigawatt of encapsulant capacity and 3 gigawatt of backsheet capacity. So traditionally, the company is in business since 2011 in India for EVA backsheet, and in 2015 we expanded into solar modules and cells. We have been exporting our products to 44 plus countries. The special part here is that we as a company have got European automated lines. We have inbuilt a lot of inspections, including IoT, EL, plus we have our own innovation lab, which is actually already accredited by Intertech. So we can do all those kind of testing, which are ideally done by the testing labs like UL, TUV, Intertech, VD. And we definitely not only focus on the quality, but also the reliability of the modules. Yes, as far as bankability is concerned, we as a company have got all sorts of certifications in place. Our modules are backed by Munich Re, performance warranty are backed up by Munich Re. We also have done the bankability study through DNVGL, and we also have conducted IC 3 times testing, which is otherwise called thresher test. So this is a brief about Renesas. Now, as Dr. Sanjay, I think, has already covered majority of the part. I think what I will start with, the doctor, is the module and cell manufacturing scenario in India, the capacity, installed capacity, utilization, and the product mix available today.
Yeah.
So if we all see that today, the annual installed module capacity, I'm talking about installed capacity, is approximately 10 gigawatt in India, and comprising of 160 module manufacturers plus. Now, out of this, if we see that top 5 module manufacturer itself comprises the 50% of capacity, and majority of them are having, SE, they are in SEZ, not in DTA. The capacity utilization has been very, very low in India because I'll cover this part in the next one, that why low cost countries have, what kind of advantages they have got over Indian manufacturers. Traditionally, India, that last year we did 7+ gigawatt, out of which 80% has been imported. So the savior for us has been the SECI programs, the other, Make in India programs, where we have been able to push our products. And the utilization in India has been only 40% levels. As far as the product mix is concerned, India traditionally, if we talk about multi-modules, because we have been, India is traditionally considered as a very low-cost market, and we have, we have been in, majority of our production has been into multi-cells only. So we have in multi 330 till 340 watt peak levels. In mono PERC, India has already reached full cell. I'm talking about mono is mono PERC is already reached up to 380 watt peak. When we talk about half cut, as Dr. Sanjay said already, that what are there are inherent advantages of using half cut cell modules. We are already from 390 till 400 watt. We are already having that product line also, product mix also. Now, yes. Outside India, I think bifacial also is catching up. India do have that product, but Indian market as such is not ready, because as he already mentioned, that it is not only the product, it is also how it is deployed and what is the substrate down. So there are a lot of other parameters which are considered in using bifacial modules. That's why in India typically has not been a very great scenario as far as bifacial is concerned. There is only one manufacturer having a single line of bifacial in India. Coming back to solar cell, if I say bifacial module manufacturing, I think anybody and everybody can manufacture, because the manufacturing process will not change, only the cell is changing. Whereas when you talk about solar cells, definitely there is only one manufacturer, because the cell line totally has to be changed for that. So as far as solar cell manufacturing capacity is concerned, India has got 3 gigawatt already installed capacity, and there are 14 plus manufacturers. Out of that, top 5 cell manufacturer comprises of almost 75 to 80% of the capacities. India, as I mentioned already, that we are traditionally into multi-cell manufacturing, and the average efficiency is in between 18.6 to 18.8. There are manufacturers who are also doing mono PERC, wherein they are able to achieve 21.6% levels. Your utilization again here has been very, very low. In fact, there are a couple of big manufacturers who are not operational, so the utilization has not been more than 50% here. So this has been the Indian manufacturing scenario, whereas we know already that today see the very difficult thing to absorb here is that the solar industry as such has been obsolescence has been very, very high here, and because there are multiple small capacity manufacturers, it has been very, very difficult for Indian industry to cope up and compete with the low cost countries. Now I'm again and again telling low cost countries, because we all know where I'm heading to. I'm basically saying that low cost country here I'm referring to as China. Of course, I still recall 2007-8 when I started my solar journey. They were never the key manufacturers of solar. That time Taiwan used to be the major manufacturer leading the cell technology. Only because of the advantage over the manpower cost, the manufacturing was shifted there, and they had couple of gigawatt facility coming up. And since then, I think they have never looked back. And the local government has been very supportive there. Now I'll tell you, Doctor, if you allow me, I'll go to my second part, where I'm going to tell you that what are the major advantages to the low-cost country over Indian module manufacturers, and why Indian manufacturers have not been able to cope up with the global competition. Yes, can I go to that? Yeah. Please go ahead. So yeah, thank you so much. So as I mentioned that Taiwan was leading this cell technology till 2007-8, and they had all the big time producers made be, Gintech, Motec, Dell Solar, NSP, New Solar Power, and Solartech, Bixen, all the big time manufacturers were housing there only because of the advantages. And until that time, automation was not adopted so much in this industry. It was more of a manual operations. And 2007, the first bigger fab was done in China by a company called Dell Solar and Motec. And since then, China has always, the first the facility was itself a gigawatt facility. So what I'm here, what I'm trying to tell you there is, not only see, the first and foremost point today, if we see about the low cost country, is that they have the value chain presence. Now we all know that when I mean value chain, it is from starting from polysilicon, ingot, wafer, cell, and module. They have all the capacities available with them. So they inherently has got the advantage over anybody else, because we all know that there is every step, there is not only the value is added, but also the cost is added, right? So every step they add some margins, and India actually starts from cell level. So the dependency is 100% in the wafer level and almost 70% in the cell level, because as I mentioned, 10 gigawatt is module capacity in India, and 3 gigawatt is the only cell capacity. So the dependency of raw material is too much. They have a value chain presence whereby they have easily the advantage of up to 10% pricing levels. If we say that step by step, if they add the margins, I'm sure that they are going to add this. This would be the advantages to them. Then when we talk about other thing is the economies of scale. We all know today 100 gigawatt plus is the capacity of China itself. The good part here has been that, as far as manpower cost is concerned, I think they are no more a low cost country, because India traditionally, if you see, has definitely will be competing them in the manpower cost, because the cost has been going up over the period of time. But yes, they have been able to adopt the latest technologies. So economies of scale has been the other big advantages to them, because not only the value chain presence, they have volumes also with them. So that has been a big so they have a lot of buying power. So this has again added to a competition to us. The third big point here is the inbuilt supply chain and the logistics cost. So when I mention inbuilt supply chain, see the associated bill of material, made be polysilicon, ingot, cell, and module, all levels, they have everything available within China, within local. So what happens, not only your logistics cost goes down, also if you see the associated cost like inventory carrying cost, the transit time, the finance, everything, it actually impacts a lot, because it easily, if you see in our kind of industry, the supply chain cost itself would be, the logistics cost itself would be in the range of 5 to 7%. So I think they easily get advantage over the logistics cost as well. Now we all know that what are they as a country also, China has got the low cost of finance available. Interest rates are very, very low there. So that also is one of the big challenge for India, because here the interest rates has also been very high, double digit, whereas they get single digit, less than 5% interest rates. So that also that is also low cost to them. Plus, not only that,
Yeah, please go ahead. Go ahead.
they have, sir?
We are able to hear you.
Yeah.
Parallelly, we are getting a few questions from the participants. Say, for example, somebody actually asking that, apart from the low cost country, so what are the things we should look about apart from the technical aspect? Of course, we should see technical aspects, but apart from technical aspect, what we should see while, procuring or selecting a PV module?
So I'm coming to that, sir. This was with respect to the advantages to them over the Indian company. As I was telling you, the advantages to them because of the economies of scale. See, for them, it is very, very easy to adopt any new technology. Just imagine a company in India having couple of lines, and if you need to change over, if you need to stop his existing line, his production is completely stopped. Whereas they have multiple lines, even one or two lines, if they adopt the new technology for it, it is very easy for them. Plus, and that's exactly the reason, if you see, traditionally multi and mono has been normal multi and normal mono were the only products, and China has been able to now cope up all the mono. They have converted into almost 80% is already converted into mono perk and perk cell, and also the bifacial. So what I'm trying to convey here is not only it is advantages over the economies of scale, but it is also advantage for them to adopt to a new technology. They can make anybody else obsolete within no time, because for them to adopt technology is very, very easy. So I'm coming to now third point. What you're referring to is quality of module, right?
Yeah.
Quality of product. That's what you're referring, right?
Yes, sir.
So what do you feel is responsible to build a quality of module?
Yes.
So basically, it cannot be pinpointed that what actually would be responsible to bringing the quality of module. It is basically a combined effort of not only the processes you have, not only the type of equipments you use, the input raw materials, the level of inspection you do, including your incoming quality control, outgoing quality control, or the inline inspections you have. Moreover, you see today packing, storage, handling, transportation, the do's and don'ts, the site handling also play a major role. Plus, over and above that, the bare minimum mandatory part, which is called certification. So all these things play a very crucial role in building a quality product. So because when we talk about quality, see, it is a perceived thing, right? You have laid down the specifications and you try to match over that. So that's where the quality of module we talk about. I'll just simply give you an example of equipment. You see, the equipment, when you talk about selection of equipment, so there is equipment, a taber stringer, if you talk about, see, because we are handling a solar cell, which is a 180 plus minus 20 micron thickness kind of thing. You cannot handle the cell by bare hands. It will simply break. So if you are handling such kind of product, you need to have equipment in place which should be capable, which should have the lowest breakage rate, which should be able to give you a very good solderability. The temperature variation should be very least. The crack should not see, like if you talk about soldering, the soldering can be done by IR process, by actual the guided basis, where you are pressing the interconnect over the bus bar, and then by heating it you are soldering it. So soldering can be done in a different ways and means. But when we talk about the type of equipment, like I'll give you our example. As a company, Renewsys are using, all our taber stringers are Team Technique, where it is IR soldering, infrared soldering, and which gives you a very proper soldering alignment. The breakages are least, because just imagine the 1/3 of the cost you can get equipment which will give you a touch-based soldering technology, a guided roll guided technology, which is actually touching your metal portion, which is your interconnect, and there can be all the chances that it will touch your silicon portion in the cell, which can break. So what I'm saying, the type of equipment here. Then when we talk about processes, so see, there are India, typically, if I give example, India, there are people who don't even have the process, like something called we do not even do that silicon sealant. There is no setting time. We are not doing that only. So what happens, we have a chamber in place which is humidity and temperature controlled. Environment is there, where when you put your laminate and when you put your frame aside, there is a silicon sealant which is actually responsible for joining laminate with the aluminum frame. So what we do is the silicon sealant basically has got a setting time, which is actually prescribed by the manufacturer. So none of the Indian manufacturer, very few of them, has got the chamber where they are trying to set this silicon sealant. They simply do the framing and then simply do the testing and pack it. A third important point here is that when we talk about process, the lamination process, again here also, if you see the type of lamination equipment they have, it is very, very difficult. You see, 1/6 of the cost the lamination machines are available. The temperature variation in the lamination is 2.5% there in the normal, low cost equipments. Plus, there are, when we talk about inspection, see the level of inspection you carry out, the level of equipments you use. Like I was telling you that we have adopted the, EL, our EL equipment can inspect, or the megapixel level camera we have is a 23 megapixel camera. Just imagine that if you have a 2 or 5 megapixel camera, what kind of resolution you're going to get and what kind of cracks you can attend to. So what I'm trying to convey, that equipment, the level of inspection you do, so all these things are very, very important. Then coming to packing, if you talk about packing itself, see, people try to reduce cost there as well. So if you have a proper 7-ply packing, palletized shrink wrap, proper shrink wrap packing, then you will have, because while it is moving, it is not a static load, it is a dynamic load happening. So all these things are very important. Storage, people store it outside, there is humidity, temperature. You need to have a proper storing facility. We have a multi-stack movable racking system. The handling which you do, handling today has been a very, very major issue in India, because people do not have the lot of automation in place. Handling has been a very important. Plus transportation. So transportation, when we talk lashing, choking of the the pallets, while you are transporting it, site handling is another very, very big thing. If you see, you have done all the best things in place, and if the panels are not handled properly inside, I think you're all jitna bhi aapne mehnat kara hai, pura sab aapka waste ho jayega, sir. So it is very, very much important to provide your customer with proper manuals, not only storage, handling, unpacking, installation and commissioning. Everything should be mentioned. And also, then how do they maintain it? What kind of water they should use? What kind of pressure they should put it in the module? So all these things are very, very important. So all these things play a very, very major role in providing, in building a quality module. And I think I can tell you that today India is definitely capable. I think there are majority of the companies are getting into automation. They are getting into the best of the equipments, the inspections, and so we definitely are coming in line with the global levels. Yes, in terms of technology, there is still a lot to be done, because as I was telling that it is very, very difficult. The oscillation is so high, the investment is also so high. Typically, module is not that capital intensive, but cell and below all the value chain, it is a lot of power and capital intensive industry, wherein in India it has not been so cohesive environment. But yes, now post COVID, I think we are hearing that government is now working on the model where they are going to provide land, electricity, water.
I think we have the last few minutes for the webinar, but I will just interrupt you because there are many questions people are asking. So it will be great, you can. So there is a question from the participants that, for example, they have asked PID issues are there nowadays in the modules and how to deal with it. So what kind of things you as a manufacturer doing to handle PID issues?
Wonderful, wonderful question. Thank you. I think it has been a problem which has been which we are listening in market since now almost a year plus. I think it has cropped up suddenly, because the degradation is up to 30% levels. So see, it can be attended in 3 levels. I think it can be in the cell level itself, if you can attend it to it. Like as a company, what we do is also at cell level we can do PID testing. Plus the encapsulant which we are using, we ourselves are the manufacturers. It is PID resistant. So in the module level also, you can, by including the PID free PID resistance EVA, you can adopt it, or at the your system level, where you can do a negative grounding. So we as a company are already taking care. We use PID free cells only, and moreover, above that, we also provide use of a PID resistance encapsulant. In fact,
Okay.
we as a company, sorry.
Yeah, this is good. There are some people who are asking about the micro cracks which happens in the PV module. So of course you have highlighted you are having the 23 megapixel inline camera which is detecting the cracks and all. But are there any other ways and means, like during transportation also module develops a lot of cracks? So how you handle that?
So as I was telling, sir, that that's the reason I gave you perspective of that. Not only the equipment, process, storage, handling, everything is very, very important. You rightly said it, that you did everything best, and when you are transporting, the cells can come with a crack. See, I'll tell you, we use 7-ply packing. Uh, so plus the loadability also goes along with that, and most importantly, the lashing choking. When you transport the pallets, if it is not tied properly, and if the pallets are having some gaps, and they can move during the transportation. So what we do is we properly lash it, choke it, and as I mentioned, these are all palletized load. We always see that the loading is not done. 1+1 is the standard process we adopt. We don't do more than 1+1 stacking.
Yeah, I
Plus, as
think
I mentioned that, as I mentioned that, whenever we are dealing with our customers, we provide them a proper manual, which not only gives you the checklist. How should you unpack it? How should you unload it? So all these do's and don'ts are also conveyed to the customers. So this is the way I think you can educate your customer and avoid this thing.
Yeah, you are right. We have a participant who's Utsav Shah. He has asked us that would you like to explain the share of different market share of different technologies in India in last 5 years? So, like of course, PV module technology. So, do you have some data about the market share of different technologies?
Sir, as I mentioned that. Till last year, I think the multi-crystalline technology dominated it. I think 70% has been multi-crystalline only, and 30% were mono-PERC. This year definitely, we see a jump in mono-PERC. But if you see utility scale manufacturers, they are actually adopting bifacials as well. So a bifacial share from nowhere possibly can go up to 5 to 10, 20% at least. And the second biggest is going to be the mono-PERC only. In fact, if you see, as far because we all know that India typically has got the lowest bidding. Reverse auctions are very, very common, and we have the lowest cost today. Because of that, people are trying to adopt so they are trying to take out the maximum per watt, per square meter output. So how they are doing it is basically they are adopting a mix of technology. It is half cut, mono-PERC, bifacial with trackers, SAT, single axis trackers. I think this combination is a killing combination, whereby you can get much more output, at least 30% increment you can get over the normal otherwise output.
Yeah.
So you are actually optimizing all these technology. Half cut you are optimizing, your cost goes down. You get more output because of, as you have already mentioned that what are the benefits of half cut. They reduce resistive losses, higher state tolerance, and all those things are already there, right? So they are. So this is something which I feel is the future. Half cut, mono-PERC, bifacial with a single axis tracker. I think this would be the best combination. Plus, I think HJT, heterojunction. I think that is something which today, unfortunately, there are only a couple of players, Panasonic and now REC. I think they are the only players available. although the cost seems to be, very, very high for that because of the volumes possibly. But I think that is a very, very, a good technology and futuristic, because just imagine that, normal 60 cell otherwise, which will give you 310, 320. I think here you are able to achieve in 60 cells 365, 370 wattage. So your per square meter output goes up immediately by 10%. So your BOS cost also reduces, your land cost, all other associated cost also can reduce substantially. So that
Yeah,
is another
Bhupinder,
technology.
there are few people who are in this concern that post-COVID companies will be preferring India as the manufacturing base, and India has been traditionally doing just laminating and assembly of solar modules. So, what do you think? Like, how much time India will take to reach to a level where we will be doing everything in the country, right from the wafers to the cells to the module?
So, am I audible, sir?
Yeah.
Yeah. See, very good question. I think, very, very difficult to answer that question, because, as I mentioned that, India traditionally has been a very, very low capacity utilization, not only capacity, but also installed capacity, but the utilization also has been very low. See, we need to understand one thing, sir. I'm just giving you perspective from a manufacturing, say. See, please understand, a manufacturer can expand. As I mentioned that other countries, they'll have this advantage. They have multiple lines. They can immediately, adopt a new technology. For India, see, the environment has to be made cohesive. The government has to come into picture. As I mentioned that it is not only, a simple investment. I think as far as investment is concerned, I think Indian companies have already invested a lot. If you see, I think within last 3 years, we have already more than doubled the capacity of module, right? And in fact, we are producing a monoperk, we are producing bifacial, but people have to accept that. Plus, the most important part here is that acceptability has to come. If I am able to utilize my capacity more, if I am able to utilize, say, 100%, say 90% also from 50%, don't you feel that the cost is going to come down? So competition definitely is there, but at the same time, if you want to grow the local market, the environment has to be made cohesive. See, any new company coming up in any province in China, I think the first thing what they do is they built a power plant, sir. The cost available to the power cost to them is nothing, sir. Today in India, what is the cost you pay, sir? Commercial cost. So what I'm saying is the environment has to be made cohesive. Not only the electricity, water, not the land. See, the type of land you require. Then the other associated materials availability. So definitely what I see is, with if we start working now, I think within couple of years we'll be definitely ready, because in module as such, I think we are already there, but we need to catch up in the other value chain, cell and further below.
Of course, you are right. Hopefully, in the cell and wafer, we will become competitive in due course of time. It has not taken much time to become competitive in terms of our module manufacturing capacities. And thank you very much, Bhupinder.
So one thing I wanted to say, sir, one thing I wanted to say here. See, I think, as our Prime Minister has also said that we have to be vocal for local. I think it is time now we strengthen our manufacturing. See, because manufacturing is a core industry, sir. So if you support your industry, I really have very high regards for Japan. See, the companies like Sanyo, there are so many, Kyocera. See, there are big time companies in Japan, sir. I think they have the lowest imports today. So they still have very high regards for their product, and even though their product is costly. What I'm trying to say that definitely we'll compete with them. We have already started competing with them in terms of manufacturing cost per se, but then the availability of raw material, the associated cost, as I mentioned, logistics have been challenges. And I don't think now there is so much of difference in cost, sir. I think it is reducing day by day. I think if you see, compare last 3 years, I think you will see the difference has come down substantially now. So what I'm trying to convey is that, we need to support industry, and manufacturing is core industry. If we support them, I think, all the associated business will start growing. I think India will be, self-sufficing.
Yeah, you're right. You're right, Bhupendraji. So thank you very much, Bhupendraji, for your valuable time to our participants. And I am equally thankful to our patience hearing of the participants to this webinar. We are sorry for a bit of technical glitch, and hopefully we will be covering this topic once again so that we can take
I think I would say that I had a lot to say. I did not even touch about the reliability, which I am very passionate about, because we as a company believe in reliability, and because just imagine, we are only talking about quality, sir. So quality is
yeah,
something which has to be in DNA. I think I need not to teach my worker that you have to do
yeah,
this every day. It should be in DNA. But what you talk about, when you talk about reliability, it is not your normal process, sir. So,
yes,
you do a lot of other extended life testing in your modules, whereby you also try to see that in the harsher environments how it is going to perform in the field. So we do have our innovation lab, which is capable of doing humidity freeze, damp, heat, thermal cycling, UV exposure, PID, everything we can do in house, sir. So these are the tests which I wanted to touch upon, but I think, as I told you that, 5 o'clock I have another webinar to attend. So I would thank you so much for giving this opportunity, and I would definitely like to say sorry to all the participants, because the delay. I think it has impacted covering the complete the, whatever we had decided. I think we are not able to complete the topics.
yes, yes.
So
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 maybe
thank you very much.
we'll cover up a few things which are left out. Thank you, Upendraji, and thanks all the participants. And we end webinar here. Thank you.